Hey guys, we're going to take some data here for investigation 2 pre-lab. We want to create a spectrum of wavelength versus absorbance for copper 2 nitrate. We're going to blank our spectrophotometer with some distilled water, and then we are going to use a cuvette of copper 2 nitrate. This is 0.4 molar copper 2 nitrate. And we are going to take absorbance at a bunch of different wavelengths. We're going to start at 400. We'll go every 20 nanometers all the way up to 700. So you are going to have to write down this data in your notebook. Again, your independent variable that we are changing is going to be wavelength starting at 400, and it'll increase every 20 nanometers up to 700. Your dependent variable is going to be the absorbance of light at each of these wavelengths as it travels through your copper 2 nitrate. Okay, so I'm going to zoom you in so that you can read the spectrophotometer yourself, and you will be able to see me change the wavelength. I'll tell you what wavelength I'm at, and you're going to want to write down what the absorbance is. Now, the purpose of doing this is so that we can create a spectrum, and from that spectrum we can evaluate it and figure out what the best wavelength is going to be in order to absorb copper 2 nitrate. We'll talk about what's doing the absorbing and how we know that. And then later on, we're going to look at a sample of copper from another source, which is the shell or the casing of a shell, which is made out of brass. So that has a source of copper in it, and we want to determine how much copper is in it. So we're going to set ourselves up now to figure out what wavelength we want to use to do that evaluation later. All right, I'll get my Kim wipe, clean off my distilled water sample. We'll put that sample in, and then we're going to blank the cuvette. Now we're going to put in our sample of copper 2 nitrate. 0.4 molar copper 2 nitrate, and the wavelength right now is set at 400. So you can see the absorbance is reading negative 0.004. I'll change this to 420. Negative 0.137. Change this to 440 nanometers. Negative 0.148. 460 nanometers. No absorbance reading. 480 nanometers. No absorbance reading. 500 nanometers. No absorbance reading. 520. No reading. 540. No reading. 560. Negative 0.152. 580. Negative 0.106. 600. 0.049. 620 nanometers. 0.272. 640 nanometers. 0.747. 660 nanometers. 1.4 2.19, let's say. 680, 2.111, 700, error. 720, no absorbance reading. 740, no absorbance reading. 760, no absorbance. 780, no reading. 800, no reading. Okay, so now you're going to graph that wavelength versus absorbance. Print that out. You want to make a scatter plot. Do not connect the dots. So scatter plot, label your axes, give it a title, and we are going to use that graph to talk about what wavelength we should use to get maximum absorbance within our little guy's range of capabilities. So we're going to choose a wavelength for max absorbance for copper 2 nitrate.